In this video, we will demonstrate how to use your diamond engineering tools to examine measured gain parameters and compare them to the total available gain parameters. A typical antenna link consists of a transmission antenna fed from a source with the receiver and the equivalent of the length in terms that can be mathematically analyzed in the simple schematic. The ability to separate the power being returned from the antenna from the power being transmitted to the antenna is accomplished through a traditional coupler. The coupler separates the forward traveling wave from the reverse, and it has its own set of S parameters. So we have the source, the coupler, the antenna, the link, and the receiver. From simple network theory, it is well known that for the case of a reciprocal lossless network, the gain in terms of the maximum gain available and the mismatch return loss is given by the gain function of the as-L and the frequency times 1 minus the S11 squared. When we perform a measurement as shown in the schematic, we measure the AUT gain, leaving us wondering what the AUT available gain could be if it were properly matched. The AUT available gain is then the maximum gain divided by the return loss. 1 minus S11 squared is defined as return loss. To begin with, we're going to first load up the Diamond Engineering dipole, which is located in your advanced data directory. This dipole was designed, built, and measured here at Diamond Engineering and has already been processed for gain. The gain is, by default, stored in registered 4. If we recall the gain and go to the scientific calculator and position it at maximum azimuth and elevation slider settings, we can see that the gain for this dipole peaked at about 2.18 GHz at 4.9 dB. The match of this dipole was also measured at the time using alternate parameter in the test equipment menu. We're going to hold the gain plot at its maximum and we're going to recall the alternate parameter data. Here we have the mismatch of the antenna superimposed over the gain of the antenna. If we then ask ourselves, if this mismatch were not occurring, if we had an ideal match at every single frequency, what would this profile look like? And that is the very subject of this video. One of the more useful functions of the scientific calculator is the return loss button. The inverse of that button is match. We're going to calculate the return loss for this profile S11 and output the results to register 0 for later use. To begin with, we'll first recall Reg 3 and calculate the return loss. It tells us that it's been transferred to Reg 0, and so I'll save this into Reg 2. We can now see from the profile that the return loss offers a negative value of increased gain. If we transfer that as a positive gain, we simply take 1 over that value, and we can see that these gain numbers will be added to this gain number. Remember, from our simple available gain equation, we're going to want to divide the measured gain by the return loss, 1 minus S11 squared. Now we're ready to calculate the available gain of the measurement in register 4. First, we'll recall Reg 4, and we'll slide the sliders to the max as L and utilize the hold button in order to hold the plots so we can divide that by the available gain in Reg 2. We now see the available gain come up and make the division. We can see that we have significantly increased the gain profile for the dipole. So if we were to match the dipole perfectly at any one of these frequencies, or if we were clever enough to have a matching circuit that would do this automatically, this is the kind of gain profile that could be potentially generated. And that concludes our tutorial on the advantages of examining actual gain versus the available gain. If you have any questions or comments, please feel free to post them here, send us an email, or even give us a call. Thanks for watching.